Kepler 10b. Kepler 10b is a rocky exoplanet, classified as a super-Earth because it is larger and more massive than Earth, but still primarily made of rock and metal. It was discovered in 2011 by the Kepler Space Telescope using the transit method, when the planet regularly crossed in front of its host star and caused tiny dips in starlight. Follow-up radial velocity measurements confirmed its mass and density, making it the first definitively identified rocky planet outside the solar system. The planet orbits about 560 light-years away in the constellation Draco. It is roughly 1.4 times Earth's radius and 4.6 times Earth's mass. With these proportions, its gravity would feel more than twice as strong as Earth's. A human who weighs 150 pounds on Earth would weigh over 300 pounds on Kepler 10b. The world circles its star in less than 1 Earth day. Such proximity makes it tidally locked, with one side locked in permanent sunlight. The star-facing hemisphere reaches surface temperatures around 3,000 degrees Fahrenheit, hot enough to melt iron. The planet likely has vast magma oceans, while the cooler night side may be covered in hardened crust. Theories suggest the surface cycles between vaporization and condensation. Rock and metal on the day side melt and evaporate, producing a thin atmosphere of minerals, which then condense on the cooler night side and fall back as molten rock rain. Some researchers speculate that extreme irradiation may have stripped away any lighter atmosphere the planet once had, leaving only a bare, molten surface. There are also ideas that its iron-rich composition could result from violent collisions early in the system's history, similar to how Mercury formed in the solar system. Kepler 10b represents the lethal end of rocky planet possibilities. Its gravity crushes, its atmosphere is unstable, and its oceans are made of molten rock. Standing on such a world would be impossible, and imagining it highlights how fragile Earth's balance really is in comparison. 55 Cancri. 55 Cancri E is a rocky exoplanet classified as a super-Earth, with about twice Earth's radius and roughly 8 times its mass. It was first detected in 2004 by astronomers using the radial velocity method, which measured the gravitational wobble in its star's motion. Later observations of the planet transiting across its host star confirmed its size, density, and extreme conditions. The planet is located about 41 light-years away in the constellation Cancri. It belongs to a multi-planet system orbiting a sun-like star that is part of a binary system. If placed in our solar system, it would orbit far inside Mercury's orbit. Its orbit lasts less than 18 hours, meaning the planet is extremely close to its star. Surface temperatures reach up to 4,900 degrees Fahrenheit, enough to melt rock. One hemisphere, locked in constant daylight, may host a global ocean of lava, while the night side remains comparatively cooler but still far above Earth's hottest deserts. For years, scientists speculated that its composition could be carbon-rich, making parts of its interior filled with diamond. More recent data favors the model of a magma-covered world with vaporized rock in its atmosphere. The brightness variations seen in infrared suggest heat is unevenly distributed, likely because the atmosphere is too thin to move energy around effectively. Some models propose that volcanic activity might be constant, with magma plumes reshaping the surface continuously. Another possibility is that the planet's composition differs greatly from Earth's, with carbon dominating over oxygen, leading to exotic geology we do not see on our own planet. This world provokes awe because it shows two extremes at once: the idea of unimaginable riches, such as diamond interiors, and the reality of a landscape so hot and unstable it could never be touched. It is a reminder that beauty and destruction often exist together in the universe, far beyond what we can imagine on Earth. WASP 12b. WASP 12b is a gas giant classified as a hot Jupiter, nearly twice Jupiter's radius, but only about 1.5 times its mass, which makes it bloated with a very low density. It was discovered in 2008 by the Wide-Angle Search for Planets project using the transit method, when dips in starlight revealed its massive size and close orbit. Ultraviolet observations later confirmed that material is actively escaping from the planet. The planet is about 1,400 light-years away in the constellation Auriga. It orbits its host star at a distance less than 3% of Earth's distance from the Sun, completing an orbit in just over 1 Earth day. Its proximity to the star stretches the planet into an elongated, egg-like shape. Temperatures on the day side reach nearly 4,000 degrees Fahrenheit. At this range, the star's gravity pulls the outer layers of the planet away, stripping its atmosphere and forming a disk of gas around the star. The planet is losing mass at a significant rate. Theories suggest that WASP-12b may not survive more than a few million years before it is completely consumed or reduced to a rocky core. Observations of its inflated atmosphere and rapid escape support models of extreme tidal disruption. Some scientists speculate that its unusual carbon-to-oxygen ratio could mean exotic forms of chemistry in its clouds, possibly creating compounds not seen elsewhere. Others suggest the stripping process could leave behind a remnant core, giving a rare view of how gas giants are destroyed. WASP-12b is terrifying because it shows that planets themselves are not safe from cosmic violence. To witness a world being slowly devoured by its star is to see the fragility of planetary existence, reminding us that destruction can be woven directly into the fabric of orbit and gravity. CoRoT 7b. CoRoT 7b is a rocky super-Earth, about 1.6 times Earth's radius, and between 4 and 8 times Earth's mass, making it a dense, heavy world with strong surface gravity. It was discovered in 2009 by the CoRoT space telescope using the transit method, when astronomers measured the dimming of its star as the planet crossed in front. Radial velocity follow-up confirmed its mass, making it the first definitively rocky exoplanet found by transit. The planet lies around 490 light-years away in the constellation Monoceros. It orbits its star at a distance only 2% of the Earth-Sunday separation, completing a full orbit in just 20 hours. At this extreme proximity, the dayside surface temperature exceeds 4,000 degrees Fahrenheit, enough to vaporize rock. The planet is tidally locked, so one hemisphere is a furnace, while the other is in perpetual night. The day side likely hosts massive lava oceans, while the cooler side may be covered with hardened rock. Models predict a rock vapor atmosphere produced by constant evaporation from the molten seas. On the cooler night side, this vapor could condense and fall back to the surface as mineral rain, creating a planet-wide cycle of rock evaporating and precipitating. Some theories suggest CoRoT 7b may be the exposed core of a former gas giant, its atmosphere stripped away by the star, leaving only a molten rocky remnant. Others view it as a natural product of forming close to its star, where temperatures never allowed volatile materials to accumulate. This planet embodies the concept of a true hell world. Its lava seas, mineral atmosphere, and ceaseless rock rain push the limits of what we imagine a solid planet can be, showing a version of Earth twisted into something instantly deadly and forever unstable. KELT 9b. KELT 9b is an ultra-hot Jupiter, a gas giant about 3 times Jupiter's mass and nearly twice its radius, orbiting so close to its host star that it has become one of the most extreme planets ever observed. It was discovered in 2016 by the Kilodegree Extremely Little Telescope Survey using the transit method, when astronomers measured dips in starlight as the planet crossed its star. Follow-up observations confirmed its inflated size, massive gravity, and extraordinary temperature. The planet is located about 670 light-years away in the constellation Cygnus. It orbits its host star, a large and luminous A-type star, at a distance 20 times closer than Mercury orbits the Sunday. Its year lasts only 1.5 Earth days. The day side reaches temperatures above 7,800 degrees Fahrenheit, hotter than the surfaces of many red dwarf stars. At this heat, molecules break apart into individual atoms, meaning its atmosphere is dominated by atomic species rather than stable compounds. The planet is tidally locked, with one hemisphere always scorched and the other in permanent darkness. The winds of several miles per second carry some heat into the night. Scientists believe the atmosphere is continuously evaporating under the star's radiation. Hydrogen gas has been observed streaming away, forming a comet-like tail. Models predict that although KELT 9b is losing mass, its large size will allow it to survive for billions of years, though in a slowly shrinking state. Some theories propose that the planet's atmospheric chemistry could include vaporized metals and exotic ionized gases that only exist under such intense conditions. Others suggest its extreme heat makes it a natural laboratory for studying matter at the edge of stellar physics. This world represents the outer boundary of what a planet can be. With a temperature hotter than stars, an atmosphere stripped to atoms, and a body slowly eroding into space, It shows how fragile planetary identity becomes under the extremes of gravity and heat. TRES 2b. TRES 2b is a gas giant classified as a hot Jupiter, about 1.4 times the mass of Jupiter and nearly the same size. It was discovered in 2006 by the Transatlantic Exoplanet Survey using the transit method when astronomers observed its host star dimming as the planet passed in front. Later observations with the Kepler space telescope revealed its most unusual feature: its extreme darkness. The planet is located about 750 light-years away in the constellation Draco. It orbits its star at a distance only 3% of the Earth-Sunday separation, completing one orbit every 2.5 Earth days. TRES 2b reflects less than 1% of the light that falls on it. For comparison, Earth reflects about 30%, and even charcoal reflects more light. This makes it darker than coal, darker than black acrylic paint, and the least reflective planet ever found. Despite being nearly Jupiter-sized, it glows only faintly with a red thermal glow like hot embers. Scientists think its lack of reflectivity is caused by the absence of reflective clouds in its atmosphere. The planet's high temperatures, around 2000 degrees Fahrenheit, likely destroy condensates that would normally scatter light. Instead, gaseous sodium, potassium, or vaporized metals could absorb most of the incoming starlight, leaving the planet black. Some theories suggest that turbulent atmospheric circulation might also contribute, preventing reflective particles from forming. Another possibility is that exotic chemicals dominate its upper atmosphere, trapping almost all light. TRES 2b shows how a giant planet can hide in plain sight, nearly invisible next to the glare of its star. Its existence forces us to realize that even massive worlds can become shadows, challenging our assumptions about how planets should look, and reminding us how little light is needed to conceal an entire planet. Gliese 436b. Gliese 436b is a Neptune-sized exoplanet, about 22 Earth masses and 4 times Earth's radius, classified as a hot Neptune. It was discovered in 2004 by astronomers using the radial velocity method, which detected the gravitational pull the planet exerts on its small red dwarf star. Later transit observations allowed precise measurements of its size and density. The planet orbits about 33 light-years away in the constellation Leo. Its orbital distance is only about 3% of the Earth-Sunday separation, and it completes a year in just 2.5 Earth days. The surface temperature is around 1,200 degrees Fahrenheit, yet the planet is covered in ice. This is not ordinary ice, but a form of hot ice, created by the immense pressure deep inside the planet. Gravity squeezes water molecules so tightly that they remain solid even under blazing heat. At the same time, the upper atmosphere is scorching, creating a paradoxical combination of fire and ice. Scientific models suggest that the atmosphere is being stripped away by stellar radiation, leaving behind layers of compressed, superheated water and hydrogen. The planet's density indicates a large water content, but the extreme conditions transform it into exotic forms of ice and vapor unfamiliar on Earth. Some theories propose that Gliese 436b may have once resembled Neptune, but migrating close to its star boiled away lighter gases, leaving behind a superheated icy core. Others suggest chemical processes in its deep atmosphere could produce even stranger states of matter, such as ionic water or superionic ice. This planet provokes awe because it defies intuition. It shows that water, the most familiar substance on Earth, can exist in bizarre, deadly states under alien pressures and heat. A world of burning ice demonstrates how our everyday elements can become lethal and incomprehensible in the extremes of the universe. HD 106906b. HD 106906b is a massive gas giant, classified as a super-Jupiter because it is more than 10 times Jupiter's mass. It was discovered in 2014 using direct imaging with the Magellan and Hubble telescopes. Unlike most exoplanets, which are found by wobbles in starlight or transits, this one is so far from its host star that astronomers could photograph it directly. The planet is located about 300 light-years away in the constellation Crux. It sits at a staggering distance of around 650 astronomical units from its star, which is more than 20 times farther than Pluto is from the Sunday. To put that in scale, the entire solar system could fit inside its orbit many times over. What makes HD 106906b extreme is not just its size, but its distance. At such a remote orbit, the planet challenges models of planetary formation. It is so far from the star that it should not have formed in place, yet it exists, orbiting like a rogue body, barely bound to its system. Theories suggest that the planet may have formed closer to the star before being thrown outward by gravitational interactions with other massive bodies. Another possibility is that it originated outside the system entirely and was captured by the star's gravity. Some scientists speculate that objects like HD 106906b blur the line between planets and brown dwarfs, possibly representing failed stars. Others suggest it could host moons with environments warmed by internal heat, though this remains speculation. This planet symbolizes isolation on a cosmic scale. Its lonely orbit, far from the warmth of its star, reflects the cold emptiness that dominates most of the universe. It reminds us that many worlds exist at the margins, in darkness, cut off from the stability that makes Earth possible. Kepler 70b and Kepler 70c. Kepler 70b and Kepler 70c are both rocky exoplanets orbiting an extremely hot subdwarf B star. They are classed as ultra-short period planets because they orbit in just hours, at distances far closer than Mercury is to the Sunday. They were discovered in 2011 by the Kepler Space Telescope through the transit method, when astronomers observed tiny, rapid dips in starlight caused by the planets passing across the star's surface. Their orbital timing and unusual host star made them stand out immediately. The system lies about 4,400 light-years away in the constellation Cygnus. Kepler 70b is about 75% the size of Earth and orbits its star in just over 5 hours. Kepler 70c is larger, close to Earth's size, and completes its orbit in just over 8 hours. The entire orbits of both planets could fit well inside the radius of the Sunday. What makes them extraordinary is their survival. Their star is the remnant of a once normal star that expanded into a red giant and then collapsed into a scorching subdwarf. During that process, the star would have swollen past the planet's orbits, engulfing them. Yet both still exist, circling incredibly close to the remnant star. The leading theory is that these planets were once gas giants. As the star expanded, their gaseous envelopes were stripped away, leaving behind only rocky, metallic cores. This explains their extreme density and resistance to the catastrophic stellar evolution of their host. Some scientists speculate that more planets like these may exist, hidden around stellar remnants. If true, they would provide rare opportunities to study how planetary systems evolve after the deaths of stars. These planets provoke awe because they are survivors of cosmic death. Where we would expect only destruction, they endure as scorched, naked cores orbiting a stellar corpse. They symbolize both the violence of stellar death and the persistence of planetary remnants, proof that even after cataclysm, fragments of worlds can remain. PSR B1257+12 planets. The PSR B1257+12 system contains 3 known exoplanets. They are classified as pulsar planets because they orbit a pulsar, the collapsed core of a massive star that exploded in a supernova. These planets were discovered in 1992 by astronomers Alexander Volchan and Dale Frail using the Arecibo radio telescope. They detected regular variations in the pulsar's radio signals caused by the gravitational tug of orbiting planets. This was the first confirmed discovery of planets outside the solar system. The system lies about 2,300 light-years away in the constellation Virgo. The planets are much smaller than Jupiter, with masses comparable to Earth and the Moon. Despite their small size, their location around such a hostile star makes them some of the most extreme known worlds. What makes them unique is the environment they orbit in. A pulsar emits powerful beams of radiation that sweep through space like a cosmic lighthouse. Any nearby planet is bathed in deadly X-rays and gamma rays, which sterilize surfaces and make atmospheres impossible to maintain. These are worlds of constant radiation bombardment. Theories about their origins suggest that the planets may have formed from the debris disk left behind after the supernova explosion. Another possibility is that they were captured after the star's collapse, surviving in spite of the violence that destroyed the original system. Some scientists speculate that pulsar planets could be far more common than currently detected, hidden because their small size makes them hard to identify. There are also ideas that such extreme radiation environments could drive exotic chemistry unknown on Earth. These planets highlight survival in the harshest conditions imaginable. Orbiting a corpse of a star, drenched in lethal radiation, they symbolize the resilience of planetary formation but also the cosmic indifference to life. They remind us that not all worlds are havens, some exist only as scorched remnants circling the aftermath of stellar death. NGTS-10b. NGTS-10b is a gas giant exoplanet, classified as a hot Jupiter with about twice Jupiter's mass and a radius slightly larger than Jupiter's. It was discovered in 2018 by the Next Generation Transit Survey, or NGTS, using the transit method. Astronomers measured the dips in starlight from its host star and confirmed its mass with radial velocity observations. The planet is located about 1,060 light-years away in the constellation Taurus. It orbits its star so closely that a full year lasts only 18 hours. For comparison, Earth takes 365 days, meaning NGTS-10b completes nearly 500 orbits in the time Earth finishes one. Its extreme proximity places it at risk of destruction. The planet is nearly at the Roche limit, the distance where tidal forces from the star can tear a planet apart. It is already distorted into an elongated shape by gravity, and scientists believe it may eventually be ripped apart and consumed by its star. Theories suggest that NGTS-10b may have migrated inward after forming farther out in its system, gradually spiraling closer until it became trapped in this unstable orbit. Such extreme migration challenges models of planetary dynamics because very few giant planets are found at this limit. Some speculate that if it survives long enough, NGTS-10b could lose its atmosphere entirely, leaving only a dense, rocky core behind. Others believe it will be destroyed completely within a few million years, a short lifespan on cosmic scales. This planet is a symbol of precarious existence, locked in a deadly dance with its star, stretched by gravity and whipped through an 18-hour orbit. It shows how even giant planets can be doomed by the very forces that hold them in place. TOI 849b. TOI 849b is a dense exoplanet, about 40 Earth masses and 3.5 Earth radii, making it larger than Neptune, but with far greater density. It is classified as a super-Earth or mega-Earth, though its unusual nature suggests it may be the remnant core of a former gas giant. It was discovered in 2020 by NASA's Transiting Exoplanet Survey Satellite, or TESS, using the transit method. Radial velocity data from ground-based telescopes confirmed its extreme mass relative to its size. The planet orbits about 730 light-years away in the constellation Hydra. Its orbital distance is extremely close to its star, with a year lasting only 18 hours. For comparison, Earth's orbit is more than 10,000 times farther out. TOI 849b's density is what makes it remarkable. With nearly half the mass of Saturn, but no thick hydrogen-helium envelope, the planet appears stripped down to its rocky and metallic interior. Astronomers call it a naked core, the first of its kind ever identified. Theories suggest it may once have been a gas giant, similar to Jupiter or Saturn. Either the star's radiation and tidal forces removed its atmosphere, or catastrophic collisions during its early history blasted away its gaseous layers, leaving only the dense core. Some speculative models propose that planets like this could reveal what the deep interiors of gas giants look like, structures we cannot directly study in our own solar system. Others consider that such cores may be common but usually hidden, as most giant planets keep their envelopes intact. TOI 849b is terrifying because it shows a planet can be stripped down to its skeleton. It stands as evidence that worlds can be destroyed and reshaped by cosmic violence, leaving only a dense scar of what once was. WASP 76b. WASP 76b is a gas giant classified as an ultra-hot Jupiter. It has about 1.5 times Jupiter's mass and nearly twice Jupiter's radius, making it a bloated planet under extreme stellar heating. It was discovered in 2016 by the Wide-Angle Search for Planets project using the transit method when astronomers detected dips in its host star's brightness. Follow-up spectroscopic studies with the Very Large Telescope in Chile revealed chemical details of its atmosphere. The planet is located about 640 light-years away in the constellation Pisces. It orbits so close to its star that a full year lasts just 1.8 Earth days. At that distance, it is tidally locked, with one hemisphere permanently facing the star. Temperatures on the day side exceed 4,400 degrees Fahrenheit, hot enough to vaporize metals. Observations show gaseous iron in its atmosphere. Winds then carry this vapor toward the cooler night side, where the iron condenses and falls as molten iron rain. This process creates a world with metallic storms, unlike anything on Earth. Theories suggest that the planet's inflated size is caused by internal heating driven by stellar radiation and tidal forces. The atmospheric circulation is dominated by powerful winds that move heat and vapor from the blazing day side to the cooler hemisphere, producing the iron condensation cycle. Some scientists speculate that WASP 76b could contain other exotic weather systems, with additional metals or silicates cycling between vapor and rain. Others suggest that such worlds represent a transitional stage, gradually losing material to their host stars. This planet stands out because it turns something as familiar as rainfall into a deadly storm of molten iron. It shows how extreme conditions transform even common elements into weapons of destruction, underscoring the brutality of worlds that form too close to their stars. HD 209458b. HD 209458b, nicknamed Osiris, is a gas giant classified as a hot Jupiter. It has about 69% of Jupiter's mass, but is puffed up to a radius larger than Jupiter's, giving it an unusually low density. It was discovered in 1999 using the radial velocity method, one of the earliest hot Jupiters ever found. In 2001, astronomers used the Hubble Space Telescope during a transit to make the first detection of an exoplanet atmosphere, confirming the presence of hydrogen. The planet is located about 159 light-years away in the constellation Pegasus. It orbits its star at just 7 million kilometers, less than 5% of Earth's orbital distance. Its year lasts only 3.5 Earth days. Osiris is extreme because it is evaporating into space. Ultraviolet observations revealed an extended cloud of hydrogen thousands of times larger than the planet itself, streaming away as stellar radiation strips its atmosphere. The planet is losing material so rapidly that it has been called a cometary planet, with a long, invisible tail of gas trailing behind it. Theories suggest Osiris is in a transitional phase. Over billions of years, it may lose its gaseous layers completely, leaving behind only a dense, rocky, or metallic core. Models of atmospheric escape from Osiris have since been applied to many other hot Jupiters to understand how stars can reshape or destroy planets. Some scientists speculate that Osiris represents an evolutionary link between gas giants and super-Earths, showing how extreme radiation can transform one class of planet into another. Others suggest that such atmospheric escape could seed interstellar space with material that influences nearby systems. Osiris is striking because it captures the process of planetary death in real time. HD 209458b. HD 209458b, nicknamed Osiris, is a gas giant classified as a hot Jupiter. It has about 69% of Jupiter's mass, but is puffed up to a radius larger than Jupiter's, giving it an unusually low density. It was discovered in 1999 using the radial velocity method, one of the earliest hot Jupiters ever found. In 2001, astronomers used the Hubble Space Telescope during a transit to make the first detection of an exoplanet atmosphere, confirming the presence of hydrogen. The planet is located about 159 light-years away in the constellation Pegasus. It orbits its star at just 7 million kilometers, less than 5% of Earth's orbital distance. Its year lasts only 3.5 Earth days. Osiris is extreme because it is evaporating into space. Ultraviolet observations revealed an extended cloud of hydrogen thousands of times larger than the planet itself, streaming away as stellar radiation strips its atmosphere. The planet is losing material so rapidly that it has been called a cometary planet, with a long, invisible tail of gas trailing behind it. Theories suggest Osiris is in a transitional phase. Over billions of years, it may lose its gaseous layers completely, leaving behind only a dense, rocky, or metallic core. Models of atmospheric escape from Osiris have since been applied to many other hot Jupiters, to understand how stars can reshape or destroy planets. Some scientists speculate that Osiris represents an evolutionary link between gas giants and super-Earths, showing how extreme radiation can transform one class of planet into another. Others suggest that such atmospheric escape could seed interstellar space with material that influences nearby systems. Osiris is striking because it captures the process of planetary death in real time. Some speculative models suggest the steam atmosphere could produce unusual chemistry, potentially creating hazes or photochemical compounds under the red dwarf's radiation. Others raise the possibility of water-rich planets being more common around small stars, making GJ1214b a prototype for this class. This planet fascinates because it takes one of Earth's most familiar substances, water, and turns it into something alien and deadly. Instead of oceans that sustain life, GJ1214b's oceans are boiled into suffocating steam, showing how even water worlds can be hostile beyond imagination. Kepler 16b. Kepler 16b is a gas giant about one-third the mass of Jupiter and roughly similar in radius to Saturn. It is classified as a circumbinary planet because it orbits two stars instead of one. It was discovered in 2011 by the Kepler Space Telescope using the transit method. The dips in brightness came from the planet passing in front of both stars, and detailed timing of the transits confirmed its orbit around the binary system. The planet is located about 200 light-years away in the constellation Cygnus. Its orbit takes 229 Earth days, placing it just outside the system's habitable zone. The two stars it orbits are a K-type orange dwarf and a smaller M-type red dwarf. What makes Kepler 16b remarkable is that it proves planets can form and survive in stable orbits around two stars. As it circles, the planet experiences two shifting suns in its sky, producing a dramatic double sunset. However, with temperatures far below freezing, it is a cold gas giant with no solid surface. A massive world is slowly unmade by its star, reduced orbit by orbit as its atmosphere drifts into space. It is a vivid reminder that even giant planets are temporary, fragile against the relentless forces of radiation and gravity. GJ1214b. GJ1214b is a sub-Neptune exoplanet, about 2.7 times Earth's radius and around 6.5 times Earth's mass. Its density indicates it is not a purely rocky planet but contains large amounts of volatile material, most likely water. It was discovered in 2009 by the MERTH project using the transit method. Radial velocity measurements confirmed its mass, and follow-up Hubble Space Telescope observations studied its atmosphere. The planet is located about 48 light-years away in the constellation Ophiuchus. It orbits a small red dwarf star at a distance far closer than Mercury orbits the Sun, completing a year in just 38 hours. Conditions suggest GJ1214b could be an ocean world. With its mass and radius, models predict a large fraction of its bulk is water. But at surface temperatures of about 500 degrees Fahrenheit, any surface ocean would boil away. The result is likely a planet wrapped in a thick steam atmosphere, with superheated water vapor surrounding it. Theories propose that below the atmosphere, the planet may host layers of exotic high-pressure ice phases, and possibly a deep liquid ocean beneath them. These conditions resemble scaled-up versions of icy moons in the solar system, but at temperatures far hotter than any on Earth. The TRAPPIST-1 system is awe-inspiring because it shows 7 Earth-sized worlds packed around a single faint star. Yet, they may all be fragile and hostile. This system embodies both the hope of finding other Earths and the dread that most will prove uninhabitable, eroded by their star's violence. HD 189733b. HD 189733b is a hot Jupiter, a gas giant similar in size to Jupiter that orbits extremely close to its host star. It was discovered in 2005 using the radial velocity method, when astronomers detected subtle wobbles in the star caused by the planet's gravity. Soon after, the transit method confirmed its existence as the planet passed in front of its star, allowing precise measurements of its radius and atmosphere. The planet lies about 64 light-years away in the constellation Vulpecula. It has a mass slightly greater than Jupiter's and a radius about 1.1 times larger. In terms of scale, over 11 Earths would fit across its diameter. What makes the planet extreme is its weather. Winds reach speeds above 5,000 miles per hour, and its atmosphere contains silicate particles. At around 1,700 degrees Fahrenheit, these silicates condense into droplets that form glass-like rain. The winds then hurl these particles sideways across the planet. The atmosphere also scatters blue light strongly, giving the planet a cobalt blue appearance that resembles oceans, but is instead a sign of deadly skies. Scientific models show the planet is tidally locked, with one side in constant daylight and the other in permanent night. The heating difference drives violent circulation. Ultraviolet observations reveal that the outer atmosphere is escaping into space, creating a cloud of hydrogen larger than the planet itself. Theories suggest its composition is dominated by hydrogen and helium, like Saturn, possibly with icy and rocky material in its core. Its orbit shows that planetary formation is more flexible than once thought, as circumbinary planets had long been doubted before Kepler confirmed them. Some speculate that moons orbiting Kepler 16b could experience variable illumination from the two suns, creating extreme seasonal cycles. This has fueled comparisons to science fiction worlds such as Tatooine from Star Wars. But in reality, the planet is likely a cold and uninhabitable giant. Kepler 16b is significant because it shows that planetary systems can exist in complex star arrangements, not just around single stars like the Sunday. It reminds us that Earth's situation is only one version of planetary possibility, and other systems may follow rules that once seemed impossible. Proxima Centauri b. Proxima Centauri b is a rocky exoplanet with a minimum mass about 1.2 times that of Earth, making it slightly larger but still considered an Earth-like planet in classification. It was discovered in 2016 by astronomers using the radial velocity method with the European Southern Observatory's HARP spectrograph. Subtle shifts in the spectrum of Proxima Centauri revealed the gravitational pull of the planet as it orbited the star. Kepler 438b. Kepler 438b is a rocky exoplanet about 12% larger than Earth in radius, placing it in the category of Earth-sized planets. It was discovered in 2015 by the Kepler Space Telescope using the transit method. Astronomers measured dips in starlight as the planet passed across its host star and calculated its size and orbit. The planet is located about 470 light-years away in the constellation Lyra. It orbits its red dwarf star every 35 days, placing it within the star's habitable zone, where liquid water could, in theory, exist. Originally, Kepler 438b was considered one of the most Earth-like planets ever found. However, its star is extremely active, producing frequent and violent solar flares that blast the planet with radiation. These flares are hundreds of times more powerful than those produced by the Sunday. Such activity would likely strip away the planet's atmosphere over time, leaving the surface barren and unprotected. Theory suggests that if the planet once had water or a stable climate, it has since been destroyed by its star's radiation. Any atmosphere would have been eroded into space, turning what might have been a habitable planet into a scorched wasteland. Some speculative ideas hold that underground or shielded habitats could still exist, where radiation cannot penetrate. But no evidence supports this. Others suggest that planets like Kepler 438b demonstrate the dangers of orbiting red dwarfs, which make up most stars in the galaxy. This planet is haunting because it represents lost potential. At first, it seemed like a second Earth, yet deeper study revealed it as a deadly, irradiated husk. It symbolizes how deceptive appearances can be in astronomy and how fragile the conditions for life truly are. The TRAPPIST-1 planets. The TRAPPIST-1 system contains 7 Earth-sized rocky exoplanets orbiting an ultra-cool red dwarf star. They are classified as terrestrial planets, with sizes and masses similar to Earth and Venus. They were discovered between 2016 and 2017 by the TRAPPIST telescope in Chile, and later confirmed with NASA's Spitzer Space Telescope. The discovery used the transit method, revealing multiple planets crossing in front of their dim star. The system lies about 40 light-years away in the constellation Aquarius. All 7 planets orbit much closer to their star than Mercury does to the Sunday. 3 of them fall within the habitable zone, the range where liquid water could exist under the right atmospheric conditions. Despite their Earth-like sizes, these planets orbit a red dwarf that produces frequent stellar flares. radiation bursts and charged particles bombard the planets, potentially stripping away atmospheres. Without protective magnetic fields, their surfaces could be exposed to sterilizing conditions. Scientific models suggest that if the planets retain dense atmospheres, some may have oceans, while others could be ice-covered or volcanic. But atmospheric erosion by the star is likely, meaning many of the worlds may be barren and irradiated. Some speculative theories suggest that subsurface oceans might survive beneath protective ice layers, similar to Europa or Enceladus in our solar system. Others propose that strong volcanic activity could regenerate atmospheres on some of the planets, though this remains uncertain. The planet lies just 4.2 light-years away in the constellation Centaurus, making it the closest known exoplanet to Earth. It orbits its red dwarf star at a distance, only 5% of Earth's distance from the Sun, completing a year in 11 days. Although Proxima Centauri b sits in the so-called habitable zone where liquid water could exist, its environment is likely lethal. The host star is highly active, frequently emitting powerful solar flares and bursts of X-ray and ultraviolet radiation. Any atmosphere the planet may have had is likely stripped away by this constant bombardment. Without an atmosphere, the surface would be unprotected, exposed to deadly radiation and incapable of retaining water. Scientific models show that if Proxima b retains even a thin atmosphere or magnetic field, conditions could vary drastically across its surface due to tidal locking, with one hemisphere in permanent daylight and the other in endless night. However, most evidence points toward a barren, irradiated world. Some speculative theories propose that underground regions or subsurface oceans might remain shielded from radiation, but this remains purely hypothetical. Other models suggest that strong volcanism or unusual chemistry could provide transient protective layers, though none have been confirmed. Proxima Centauri b is unsettling because it is our nearest planetary neighbor. Its presence emphasizes how close yet unreachable alien worlds can be, and how the line between potential habitability and total hostility is razor thin. It reminds us that proximity does not equal safety. Even the closest Earth-like planet may be a cosmic death trap. WASP 18b. WASP 18b is a massive gas giant, about 10 times the mass of Jupiter and slightly larger in radius, classifying it as a super-Jupiter. It was discovered in 2009 by the Wide-Angle Search for Planets project using the transit method. When astronomers observed its passage across its host star, radial velocity data confirmed its enormous mass and tight orbit. The planet is located about 325 light-years away in the constellation Phoenix. It orbits its star at less than 3% of Earth's distance from the Sun, completing a full orbit in less than 23 hours. What makes WASP 18b remarkable is how close it lies to its star. Given its immense mass, it exerts strong tidal forces that should, in theory, cause its orbit to decay quickly, pulling it into the star within a few million years. Yet it continues to exist, puzzling astronomers. Its proximity also generates intense radiation and heat, raising atmospheric temperatures above 4,000 degrees Fahrenheit. Scientific studies suggest its strong gravity suppresses atmospheric circulation. Observations show little evidence of heat being transported from the day side to the night side, leaving one hemisphere blazing hot and the other extremely cold. This imbalance challenges existing models of gas giant atmospheres. Some scientists speculate that WASP 18b's persistence may hint at gaps in our understanding of tidal interactions. Others suggest it could be influencing its star directly, affecting the star's magnetic activity or slowing its rotation. This planet provokes dread because it should not be there. A massive world skimming the edge of destruction, locked in an unstable orbit that theory says cannot last, forces us to recognize how incomplete our understanding of planetary systems remains. WASP 18b is a reminder that even the laws of orbital survival may not be as straightforward as we believe. Some scientists propose that the blue color may result from additional, exotic, atmospheric chemistry beyond silicates. Others consider that strong magnetic effects could influence wind patterns, but these remain hypotheses without solid confirmation. The image of glass rain blowing sideways at supersonic speeds reveals how alien and lethal exoplanets can be. A world like this emphasizes that Earth is a rare safe haven. In nearby systems, beauty often comes with brutality, reminding us of the thin boundary that allows life to exist here.